All right, everyone, we're going to talk about Les Chateliers with temperature and pressure. So before we get going on these problems, I want you to see the temperature as a product or as a reactant. All right, and we talked about this in the past that when it is a positive enthalpy, it means that energy is added to the chemical equation. And when it's a negative enthalpy, it means that energy is released. You would feel that as like a hot beaker. Can't think of a test tube. That's the name I was looking for. All right, so consider the reaction below. In which cases is product formation favored, which means that it needs to shift to the right side in order to form the product. So which cases is product formation favored by a decrease in temperature? So a decrease in temperature, I want you to see that as removing temperature. It makes it easier to do the problems if you actually see that as such. All right. All right, so the first thing I'm going to do is I'm going to take a look at the enthalpy, and this is negative, so I'm going to add my energy on this side, that because energy is released. This is a positive enthalpy, so I'm going to add my energy over here on the reactant side. All right, now I've got my teeter-totter. So the stress states that I'm going to decrease the temperature. So I'm going to remove the temperature, going to remove it. So if these are all people on the teeter-totter and I remove it, the stress is going to look like this drawing. Remember, the whole key is to be able to draw that. I removed that kid on that side, so that teeter-totter goes up. In order to relieve that stress, it's going to have to shift to the right side, which is going to be product formation, which is what the problem is asking for. But let's take a look at what the other one does. All right, we have energy over here as an endothermic. When I take this stress, all right, and I'm going to decrease the temperature, I'm going to remove the kid on this side of the teeter-totter, then the actual the actual stress looks like this because I removed somebody on this side. It's going to have to shift to the left side. If it shifts to the left side, it means it's going to form reactants. So that is not what this problem is asking for. So the actual number 1 is answering this question. All right, in which cases is product formation favored, again, which is going to shift to the right, by increasing the temperature. So increasing the temperature, think about that as adding temperature. All right, so again, I have a negative enthalpy. I'm going to write where the energy sits on these equations. This is an endothermic. It sits over here, okay? All right, so I need to be able to add it. So if I'm going to increase the temperature, add some more weight then on this teeter-totter, it's going to look like this. All right, in order to relieve that stress, it's going to have to shift to the left. Left means it's going to form more reactants. And that is not what this problem is asking for. All right, let's take a look at the next one. I'm going to take a look at, again, increasing the temperature. I'm going to add it. When I add it, the actual stress looks like this, right? Because I added more weight on this side. And then to relieve that, it's going to have to shift to the right side, which means it's going to form more products, which is exactly what this problem is asking for. So the answer to this one is number 2. Let's go to the bottom one here. It says, in which cases is product formation favored by a decrease in temperature? So again, decrease in temperature means to remove temperature. So why don't you pause the video now and see if you can answer these. All right, the first thing you should have done is add your energy where they belong to on each side of the equation. So hopefully we match up like that. If I'm going to remove this person from this teeter-totter, it's going to look like this. It means then it's going to have to shift to the left side, which is going to form more reactants. if I am going to remove the temperature from this side, it's going to look like this during the stress of it. Remember, these are all drawing the stress. And the result of it is it's going to shift to the right side. It's going to form more product, which is what this question is asking for. So number 2 is your answer. All right, so let's take a look at now the pressures and volumes on this next page. Okay, pressure is a little bit different. Pressure we talked about before. We had our long break here. It has to do with the number of moles. So you're constantly counting moles of the gases. Do not count any moles that have to do with solids or liquids because they are not impacted by changes of pressure or volume. Okay, so stress, if I increase the pressure, the solution to it is obviously I want to decrease the pressure. How do I decrease the pressure? I have to shift to the side with less moles. If the stress says that I decrease the pressure, my solution is I want to increase the pressure. I only can increase the pressure if I'm going to shift to the side with more moles of gas. So we're constantly counting this. Sometimes pressure is also related to as volume, and we learned that in Boyle's law, that when you increase the volume, you decrease pressure, okay? Or if they say you decrease volume, they're really saying, hey, we're increasing the pressure. It's kind of a code name here. All right, so let's take a look at what this says. In which cases will the reaction proceed more to the right by decreasing the pressure? So I'm going to define the problem. I decrease the pressure. What I want to do, I want to increase the pressure to relieve the stress. How do I increase the pressure? I want to shift to the side with more moles of gas. All right, so what I'm going to do is I'm going to add these up. Don't forget there's ones in front of here. So this has 5 moles and 4 moles. All right, so as you count up how many moles that you have of the gas, then I'm going to go and answer this question. All right, so I want to shift to the side that has more moles of gas so I can increase pressure. So to do it in here, it's going to shift to the left side because that's the side that has more moles. The side that has more moles here is the right side. So it's going to shift to the right side. So the answer to this question is number 2 because it is shifting to the right. All right, in which cases will the reaction proceed more to the right? I know these are all about proceeding to the right. They could say to the left, but I don't know. For some reason, these examples are all to the right. Proceed to the right by increasing the pressure. I do this all the time when I'm doing pressure. I define it. So that's what I'm doing to it. I am stressing out the system by increasing the pressure. And how do I relieve that? By increasing the pressure, all right? I need to decrease it by shifting to the side with less moles. So I want to decrease the pressure. To do so, I must shift to the side with less moles. Because shifting to the side with less moles will decrease pressure. Again, I need to go here and I need to add up all the moles that I have on each side. So this is 2.5. 2 moles. Be careful on these examples. I believe they're all gases, but easily on an exam problem they could have some that have solids and liquids. Okay. So I need to shift to the side with less moles. So on this side, I'm going to shift to the right, because that has less moles. On this side, I don't see any difference at all. If they have the same number of moles of gas on each side, you are in the equilibrium. It means that adding, decreasing volume, decreasing volume won't impact this, anything with the pressure. It's already in equilibrium, so nothing is going to change that. All right, now we have 2 moles on this side, needs to shift to the side with less moles. It's going to shift to the left side. And what was the question? It wants it to be to the right. And the only one that's going to shift to the right side is going to be number 1. This says, in which cases is the reaction unaffected by changes in pressure? And you could easily insert volume in there also. On any of these, you could insert volume. So instead of saying like increased pressure is your stress, I could have said decrease volume. If I decrease a volume, I'm doing the same thing by increasing pressure. So understand that this one might say decreasing pressure. But I could have also said what happens when you increase volume. So increased volume would always indicate you're decreasing pressure, and vice versa over here. So in this case, it's unaffected by changes in pressure. This is one that has the exact same moles on each side. That's how you'd be answering this question, is looking for those particular ones that have the same number of moles on each side. All right, so this is a problem in your textbook. I want you to stop the thing right now and try to solve this. This is number 77 in the back of your book. So go ahead and solve it. All right, it's my dog barking. All right, so one of the things I do to solve this is I'm going to add my energy where it belongs to, because it's an exothermic reaction. I'm going to draw the stress always. Your stress is your teeter-totter. So when I add H2 to this, think about adding more kids on this side. So this is going to be your stress. It then has to shift to the left side. If I remove iodine, think about taking someone off of this. This is what your stress is going to look like, and it's going to have to shift to the right side. HI is removed, so take the kid off of here. Boom, you could see the teeter-totter looking like this. All right, then it's going to have to shift to the left side. All right, so now we're going to take a look at, in a rigid container, I'm going to add some argon. Argon has no reaction. It's not going to react anything in here, so this does not impact the shift at all. Sometimes they like to add things like that in there. All right, so no impact, no shift. The volume of the container is doubled, so I increased the volume. That's the same thing as saying that I decreased the pressure. So if I decrease pressure, I want to increase the pressure. How do I do that? I shift to the side with more moles. I do this all the time when I deal with pressure. I define it. What do I want to do? What has to happen? So if I have to shift the side with more moles, I see that there's 2 moles here and 2 moles here. Well, what about that? It's already in equilibrium, so nothing is going to happen. It will remain as such. All right, the temperature is decreased. Remember what I said? I said it's the same thing as removing temperature. Take a look up here. What does that mean? All right, if I'm going to remove it, I'm going to take this off. All right, when I remove that, it's going to have a stress that looks like this. It's going to have to shift to the right side. All right, Le Chatelier can be difficult for many students. The key to it is writing these shifts. So the stress, so you can see where it shifts. A lot of people use their hands in order to help them to do this. This is how I solve pressures, and this is how I solve the temperatures. It does take practice, so I will be assigning problems from the textbook.